So for this example 4, what do we have? Well, of course you can ignore the numerator for a second. Our main focus is always the denominator, the nature of every single, well, by nature I mean the degree of every single factor in the denominator, and also its powers if applicable, like in this case. Well, number one, we have linears and they are repeated to the second power, so that means that we need to write the following integral. So that's a over x plus 1 plus b over x plus 1 to the second power, and because we don't have any other factors, we're essentially done with the setup. Alright, so let's do the solving the equation to the obtaining the basic equation, and also let's find the constants a and b that would give this partial fraction decomposition. So we're going to set 4x plus 7 over x plus 1 squared equals to a over x plus 1 plus b over x plus 1 squared. Alright, so we need to multiply both sides by the least common denominator to clear the denominators and simplify our equation. What is that least common denominator? What should we multiply both sides by?
X plus 1 squared.
X plus 1 squared. So of course x plus 1 works, but we need to have a power that is powerful enough to divide out all up to the highest power of x plus 1. So when we do this, notice how this cancel, and that's going to leave us with, well, let's distribute. So that's going to leave us with 4x plus 7 equals a over x plus 1. Well, we're going to be left with 1 factor of x plus 1 plus, in this case, cancel all powers of x plus 1 to be left with only a b. And that's going to be, again, our basic equation. Alright, now here is where it gets a little bit tricky, because how many letters are we supposed to find? 2. And in this case, how many convenient values do we have so we can find one of them? At least 1. Okay, so let's do that one. Okay, so let's do for, and what's that convenient value? X equals what value? Negative 1. That should work. Great. So we're gonna have 4 times negative 1 plus 7 equals 8 times negative 1 plus 1 plus b. That's negative 1, negative 1. This term will zero out, and we're gonna be left with, so 4 times negative 1, which is negative 4 plus 7, that's a negative 3 equals to b. So we're in some sort of a trap here, because what do we do in this case, Adrian?
Isn't it positive?
Positive, yes, thank you. So positive.
We evaporate, substitute the b.
We can substitute for b. So here's a like a general strategy to deal with this kind of situation. So of course, well, we don't have a value for x that is convenient, so we can zero out, for example, letter b, so we can find a, right? Actually, that b is only by itself. Well, what we're gonna do instead, we will okay, so we're going to use the value that we just obtained for b equals to 3, and in this case, for the convenient value of x, choose your favorite value. Why can we choose our favorite value? Because that value of x, we will plug it in on every instance of x on both sides, and when that happens, we're keeping our equation in balance. So you could plug in x equals 1, x equals 0, x equals 175 million, your favorite number, as long as you substitute it on both sides of the equation and every x, you should be fine. But of course, I'm not going to plug in a 6-digit number. Actually, 0 is going to work really nice. So x and x equals to 0, right? So you can pick your favorite number here, that's fine. So this will be 4 times 0 plus 7 equals a times 0 plus 1 plus b. And well, let's plug in the 0, 0, and well, so 4 times 0 is 0, that's a 7 equals a. Okay, in this case a is simply a times 1, and b, which is 3. Alright, so a equals to 4. Alright, would it work with another number? It should work. Okay, let's go back to the original problem, the integral. So this will be the integral of a, which is 4 over x plus 1 dx, plus the integral of 3 over x plus 1 squared dx. And in this case, you might want to show the u du setup. U equals to x plus 1, du equals dx. So in this case, we're going to have the integral 4 times the integral of du over u plus the 3 times the integral of du over x to the u to the second power. But of course, we cannot integrate that u squared in the while it's in the denominator. We need to move it to the numerator. With negative exponent. And well, the first one, it's just an ln. Plus 3 u to the negative 1 over negative 1 plus c. Well, let's clean up the negatives and the fractions. So that's 4 ln of u, plus, or rather minus 3 over u plus c. And just back substitute for u, that's 4 ln absolute value of x plus 1 minus 3 over x plus 1 plus c. Alright. Let me make this look like a C. Yes. Alright. Make this absolute value bar longer. There you go. Questions about anything on this example? Alright, let's have a look at the next one. So what do we have? 2x plus 3 over x cubed minus 2x squared plus 3x minus 6. Number 1, do we need to do the polynomial long division here? Do we have the degree of the numerator to be the same or larger than that in the denominator? No, it's not the case. So in this case, we can start working with the denominator. So let's factor it out. So I'm going to do that sort of on the side. Well, let me do x cubed minus 2x squared plus 3x minus 6. So what I'm going to do, because we have 4 terms, we will factor this by grouping. Group the first 2, group the other 2, and find the GCF of each group. In this case, x squared times x minus 2, and the GCF on the second group, which is 3x minus 2. And this factors the following way, as x minus 2 times x squared plus 3. Alright, let's go back to the original integral. That's the integral of 2x plus 3 over x minus 2 x squared rather, not cubed, plus 3. Alright, so what do we have over here? How should we set up this problem? What about that x minus 2? Is that a linear repeated? It's just a linear and it's not repeated, right? So only one power, that is the integral of a over x minus 2. But what about that x squared plus 3? It's an irreducible quadratic. All right. So let's set these two quantities equal to each other so we can find those values of a and a, b, and c. That is 2x plus 3 over x minus 2 x squared plus 3 equal to a over x minus 2 plus bx plus c over x squared plus 3. And well, in this case we need to multiply by the least common denominator, that is, in order to simplify this equation and cancel those denominators. So that LCD will be itself x minus 2 x squared plus 3. Okay, so when we distribute over here, notice everything cancels except the 2x plus 3. We're only left with the 2x plus 3 in the numerator. Equals, when we distribute this over the numerator on the right hand side, okay, notice how these x minus 2's cancel, leaving us with a times x squared plus 3. Do we agree? Okay, and then for the second part of the distribution here, the x squared plus 3 is cancel, leaving us with bx plus c times x minus 2. Alright, so that's actually our basic equation. Alright, so we are going to use this equation to figure out the values of a and b that will split that integral into simpler fractions. Alright, so let's see if we can have a convenient value to figure out one of those values. Do you see one? And if so, what would that value be? 2. X equals to 2, because if we plug it in here, actually takes care of both b and c, and we would be able to find a. So let's go ahead and do that. So for x equals 2, so what do we have? 2 times 2 plus 3 equals a times 2 squared plus 3 plus b times 2 plus c times 2 minus 2. Well, of course, because of that last term, 2 minus 2, that whole thing goes to 0. So we don't even need to simplify that. And we will be left with, I believe it's 2 squared, which is 4. 4 plus 3, that's a 7. 7a. And 2 times 2 equals a 4 plus 3, another 7, which is great because a equals 1. Nice numbers, not funky fractions. Alright, so we were able to only figure out the value for a. So how do we find the other values? Well, okay, so we're going to use for sure the information that we have. In this case, a equals to 1. And in this case, we are going to use our favorite value of x. Okay, which value of x that preferably cancels out one letter. So in this case, we're going to use the value of a. Any number that hopefully cancels one of these two letters. In this case, I'm thinking of the number 0, because when we use a equals 1, x equals 0 would cancel this b, and we would be able to find the letter c. Do we all agree with this? Okay, let's go ahead and do that. So I also said x equals to 0. So 2 times 0 plus 3 equals a times 0 squared plus 3 plus b times 0 plus c and times 0 minus 2. Alright, so let's see. Let's plug in 0, 0, 0, and 0. And let's simplify this one. Okay, so 2 times 0, which is 0, plus 3 equals to 3. And 0 squared plus 3 is also 3, 3a. And well, 0, that's well, actually we can plug in the value for a, which equals to 1. And well, that's fine. And that's a plus c times 0 minus 2, which is the same as saying instead, how about minus 2c? And then from here, so what are we going to get? Oh, 3 equals to 3 minus 2c, subtract 3. Negative 2c equals to 0. Divide both sides by negative 2. And that's c equals to 0. Alright? Whoops. So far we have A and C. Now we need to find the value for B. But the good thing is that we have a lot more information at this point. So in this case, we don't need to zero out any other letter. In fact, we can use our favorite number in this case. Well, let's see. So number 1, let's list what we have so far. So for A equals to 1 and C equals to 0, well, in this case we can plug in whatever value of x that we want. How about x equals to 1? Because ultimately the missing letter that we need to find is the letter B. But if we use the 0 again, it's going to get zeroed out. So we need to find to put a number that doesn't zero anything out. So in this case, x equals to 1. All right. So let's plug it in. So 2 times 1 plus 3 equals A, which is in this case 1 times, well, let me just use the same color this time to finish this quickly. So 2 times 2 plus 3 equals A, which is 1 times, what is this? X equals to 1 squared plus 3 and plus, okay, plus, and continue over here, plus B times 1 plus C, which is 0, times 1 minus 2. And over here we're going to get a 5 on the left hand side. On the right hand side, that's a 1 squared plus 3, which is 4. 4 times 1 is 4. And for B, B times 1, which is B, plus 0 is simply B. And that B will multiply with 1 minus 2, which is negative 1. That means minus B. So far so good? And well, we can solve this baby equation for B. That's, okay, subtract 4. So negative B equals 1 and B equals to negative 1. Okay? So we may go back to the original integral. Alright? Okay, let me see if I have space over here. No, that's fine. Okay, before I move on to the next page, let me show you the whole problem in case you missed anything. Okay? Are we ready to go back? Perfect. Okay, so let's go back to the integral. So I gave you a whole page, a whole blank page. Well, I don't think we're going to use the whole page, but just in case, yeah, that's fine. Okay, so initially we had the integral. Okay, let me rewrite the integral just so we can, so we have a reference of where we stopped at. So x plus 1. And the other one was bx plus c over x squared plus 3. Well, we got a equals to 4. And for B, what we got? We got. Am I doing the wrong one? So we got A. So x minus 2. Oh yeah, maybe. Yeah, I don't know where did I get this one from. So. Okay, so okay. And so x equals. So A equals 1 actually. And B, which is negative 1, negative x, plus C, which in this case is what? 0, right? Over x squared plus 3. Alright, so this first integral for this one, that's fine. No need to show, yes?
X minus 2.
X squared. Which one? It's minus this one? Oh, this one right here?
The first one. Change the x plus 1 to x minus 2.
Oh, yes, yeah. Thank you. All right. So I don't know. So I have my notes. Maybe I messed up my notes over here. But I just realized it. I just realized what I did. Okay. And, yeah. Sorry. All right. Got it. Okay, so are we good right now? Yeah, perfect. Great.
Yeah, the x is a minus 2.
When the x is a minus, this one, right?
Yep.
Yes, and a 0. Perfect. So this one, okay, let me set up a UDU for the second one. No, because I have my notes from last semester here. I had this page, this extra page, but I just realized that the work I had was from the previous example. So anyway, so u equals to x squared plus 3 du equals to x dx, where x dx equals 1/2 du. All right, so I'm going to replace this. I'm gonna subtract actually. The integral of x minus 2, and then minus the integral of du over u. That's a 1/2 outside, and well, these are both ln's. ln of x minus 2, absolute value, but for the next one, notice the difference. We don't need absolute value bars because it's a quadratic. It's always positive. It's never gonna output negative numbers, so we're fine. All right. Sounds good. Oh yeah, I had it below. Anyway. All right. Let's see.